In problem number 14, our goal here is to model this situation, this taxi charge, using a linear equation. So the taxi charge is $5 for pickup plus $2 for each mile traveled. So let's start with the $2 for each mile traveled. The amount of the total charge is changing based on the number of miles driven. So that's the rate of change of the total cost. The rate of change here is 2. So if we let the, let's say x represent number of miles, and we let the y represent total cost, then the rate of change of this line will be 2. Rate of change is slope. So this is telling us that the slope of the line will be 2. The rate of change is the slope. Here the rate of change is 2. Now the taxi charges $5 for pickup regardless of how many miles are driven. So as soon as you get in the taxi, you owe $5. If you travel 0 miles, you owe $5. That makes 5 your y-intercept, B. So the total cost is $5 plus $2 per mile. X is the number of miles, so 2x. This gives us the equation y is equal to 2x plus 5. $5 is the base fee plus $2 per mile, $2 for each mile, so 2 times the number of miles. Now, identify the y-intercepts. Well, the y-intercept is 5, and this is what I was just talking about. It's $5 to get in the cab before you travel any distance. So in the context of this problem, it's, we could say, a $5 base fee on top of the mileage charge. Now in part C, how much would it cost you to travel 2 miles? How much would it cost you to travel 5 miles? Remember, miles is your x. So what is the cost? Cost is your y. So what is y when x is equal to 2? And what is y when x is equal to 5? So 2 separate questions here. When the distance is 2 miles, or when x is 2, that means we take the 2, we plug it in for x. So when x is 2, 2 times x plus 5 becomes 2 times 2 plus 5. 2 times 2 is 4, so 4 plus 5 is 9. So for 2 miles, you're paying $9. When x is 5, we plug 5 into our equation. 2 times 5 is 10, plus 5 more is 15. So for 5 miles, you're paying $15. We now have 3 points. We have our y-intercept, 0, 5. We have 1 point from part C, 2, 9. And we have a second point from part C, 5, 15. So we have these 3 points in blue. Change this to blue. 0, 5. And so part D says you've just found 3 points from the equation in part A. Use these points to graph the line. You only need 2. Any 2 will do it. But if we graph all 3, they'll lie along, or they'll all follow along the same line. So 0, 5 is first. 2, 9 is right there. 5 comma 15 is right there. And yeah, it looks like these 3 points do fall along the same line. If they didn't, we'd know something was wrong. Notice I've drawn only the first quadrant. It doesn't make sense for x to be negative. You can't have negative miles. It doesn't make sense for y to be negative. That would mean the cab driver is actually paying you. That doesn't happen. So in the context of this problem, you're only graphing the portion of the line where x and y are both positive.